Did you know that a 1/3 of the undergraduates do not complete their degree program? 39 million Americans were categorized as college dropouts in July 2020. Detecting real-time confusion and offering instant help to understand a topic has been proven to improve the skill level and to reduce college dropout rates. TinyML solutions with inputs from EEG headsets are now able to detect confusion in real time, which is helpful in addressing the misunderstanding and confusion to improve skill level and reduce college dropout rates. There are many gaps between online education and in-class education, and one of the primary ones is detecting students' confusion level. Unlike in-class education, where a teacher can judge if the students understand the materials by verbal inquiries or their body language, immediate feedback from the student is less accessible in long-distance education. This TinyML solution addresses this limitation by using electroencephalography input from a commercially available device as evidence of students' mental states. One of the main challenges in confusion detection is the subjective nature of the cognitive state. Confusion can manifest differently across individuals and situations, making it difficult to define and identify. Additionally, confusion can be influenced by various factors such as stress, fatigue, and medical conditions, which further complicates detection. Another challenge is the need for reliable and non-invasive methods for measuring and analyzing cognitive states like confusion. EEG technology has shown promise in detecting confusion, but it requires specialized equipment and expertise to use effectively. As research in this area continues to evolve, addressing these challenges will be critical to developing effective and accessible tools for confusion detection. AITECH engineers have developed a low-code platform with templates to identify confusion using TinyML and AI sensor fuse techniques and machine learning algorithms. In this TinyML solution, the input is collected from a single-channel EEG headset sensing brain activity while students learn from the recorded video clips or live sessions. The EEG headset provides input features including raw, alpha, beta, gamma, theta, and delta signals for the dataset. Subjects and their video clips provide a clue for observers and instructors to label the confusion on a scale of 1 to 7 in a time series dataset. With this dataset collected on a TinyML platform like cAInvas or www.tinyml.studio, it is easy to create a deep learning FFNN model to detect subjects' confusion in real time. A TinyML platform like cAInvas is used to train and test deep learning classifiers for confusion detection. The model can be trained using various techniques such as feed-forward neural networks or transfer learning with pre-trained deep learning models with an accuracy of approximately 80%. The deep learning model is easily created by connecting a TinyML device to an EEG headset collecting brain signals as input on a TinyML platform like cAInvas. The platform uses pre-processing that includes normalization and augmentation, and a quick training of the model resulting in an accurate TinyML model that is compiled with deepC for inference. The solution and video thereof demonstrates a strong performance for using EEG to distinguish whether a student is confused. Further, EEG technology has shown promise in detecting confusion in various settings, including education and healthcare. Following URLs are referred to in this video. Check the description for the links. Contact us.